Hey everyone, Jason here today with a crude, rough tutorial slash proof walkthrough of the completing the square formula, or also known as a perfect square. So here we have our ax to the second plus bx plus c equals 0. This is our polynomial, where a, b, and c are in the real number population, and where a cannot equal 0. We'll talk about that in a little bit. And here is our completing the square formula. So we have x to the second plus 2xb plus b to the second equals x plus b to the second. So, what does this visually look like? Well, I got some props here, some algebra tiles. Let's assume that this right here is our x to the second. Plus, we need our xb. Well, there's two xb's. Here we go. There's two xb's plus ab to the second. And that is how that works. So this doesn't look like a square, this looks like a mess. But what if I come in and rearrange these parts in such a way that we can actually form a square? Here's our length of our x, here's the length of b. This length on this side and this side are x. So it's a perfect square. That's why they call it a perfect square. Now you don't want to hand this into your instructor, they won't quite understand that. So now we're going to do the hardcore algebra stuff. Well, for me it's easy, unless I make mistakes. So let's write our polynomial here of ax to the second. I forgot to mention this a is actually a scalar, plus bx plus c equals 0. Now, I want to get all the x guys on the left-hand side, and I want to put all the constants on the right-hand side. So here, let's do this real quick. We can clear the c out, so we're going to go ax to the second plus bx plus c minus c equals 0 minus c. Now remember, if you do something on the left, you have to do it on the right. It's just the law of math. You don't want to leave anybody out here. So now we can clear this out. That means that will be 0. And now we can come in here and ax to the second plus bx, that's cleared out, equals minus c. Not too bad. It still doesn't look like this yet. Now, let's tackle that scalar. Now, how do we do this? We want to divide this a out by 1 over a. So we're going to put all this junk in here. Okay? Now remember, you do it on the left, you've got to do it on the right. So you're going to need to do that here. So we're going to do 1 over a c. Okay? That's not too bad. Now when we do this, we can distribute these in here. So over a plus bx over a equals, well, this one here is pretty easy, minus c over a. Still doesn't look like that, but now we can cross this a out here, and then we can get our x to the second here, plus bx over a equals c over a. Now, we got this to look like that right there. So that's one part done. Now we're going to work on the middle portion of our polynomial. Well, first thing I want to do is get this x on the other side, and I think it's the law of reflexive. I'm not quite sure, so we're going to flip that around. So x to the second plus xb over a equals minus c over a. Okay? So we're not quite done now. Now we need this 2. Now how do we get that 2 in there? Well, that's not too bad. Something in here got divided out. Now we can't see it because this is actually a 1. It could be 1 times this equation. Well, let's pretend that we have 2 in there. So we have x to the second plus 2 over 2. Remember, 2 over 2 makes 1. So xb over a. Now since this is implied, we don't need to write it on the right hand side. So because we kind of factored it out of here. Now, let's distribute all this in here. 2xb over a, 2a, my bad, equals minus c over a. Alright. So now we have our 2x here, we have a 2x there. That means if I were to pull out this 2x, that means I can actually get this right here. I have to visually show you. So we have 2x times b over 2a. Let me explain how I did that. So basically I took this guy, pushed it out of the parentheses. So if you put this in there, you'll get the same answer. So if you're not sure, always put it back in there, and there we go. So now we have our x to the second, we have our 2x here, and now we have our b. So now we have the b portion. But now we got to get this b to the second. Well, that's real easy. Here's our b, we just got to add it to both sides. So now I'm going to go x to the second plus 2x. Here's the b part, 2a, plus b over 2a to the second equals c minus over a plus, my marker's running out of gas, b to the second, or b over 2a to the second. Okay, at least I'm glad I'm showing you. Okay, now for this right here, we're going to have to continue right here because I ran out of space. So right now we're going to worry about this portion right here. We'll tackle this later. So now we can just simply clean this up a bit, and how we do that is we're going to start from this right here, goes right up here. So we're going to start right here, parentheses this out. Okay, so we have x's, we have 2x right there. And with our b's, we have two of these on the side, so you can just plus those in there, and b over 2a. Someday I'm going to get a smart board and do this, but they're very pricey. Okay, so now we can just simply do our mathematical prettiness and clean this up. So if we did all this, we should have that right there. So since we have two of these, that's easy. X plus b over 2a squared. This is this. So that means now, let's clean this up a bit. And yeah, let's do that, because we need to clean this up. Math, you have to write very neat. Not like how I write. Okay, equals this stuff right here. But what I'm going to do here, I'm going to flip this over with reflexive, because I like to get rid of this negative. Reflexive, I believe, with addition, so let's do that. B second over 2a minus c over a. And I forgot to put that there. Whoops, my bad. Okay, because that would not work. So this looks good. This matches this. Now it depends on your instructor. I would clean up this right hand side. If I was teaching this, I would be like, you need to clean this up, because I like to have a common denominator. I like to have a bunch of numbers on top and just one number at the bottom. Okay, so let's see how we can do this here. Alright, so we're going to focus on just this part. This piece here is done. Let's clean this up here. Alright, so basically I'm going to combine, put this 2 in here, or this exponent here, with law of exponents. We can do this over 4a to the second. And how I got that is because we have 2 to the second and a to the second. Very trivial, minus c over a. Now remember here before we had to imagine there's a number in here, so I'm going to assume that there's another 4a in here. So basically, we have b to the second over 4a to the second, and I'm going to assume that, and let me move this down another line. Sometimes this math stuff just takes a lot of space. So let's go ahead and equal this here. And so b to the second over 4a to the second minus, remember I said we want to clear this a out. So there's another 4a in here. So we got 4a over 4a times c over a. Okay? So if we distribute those in there, you'll actually have this. B to the second, 4a to the second. So we have minus 4ac over 4a to the second. Okay? Now, we have a common denominator. A bit messy, but then here's our answer right here. B to the second minus 4ac over 4a to the second. And that right there is pretty much done. So, yes, it is sloppy. And what did we derive with our answer, since this is pretty messy? So this right here is going to be our final result. Like I said, someday I'll get a bigger whiteboard. So we already found this answer here. We have this part here. Let's put the pieces together. So we have x plus b over 2a to the second, which equals all this junk here. So b to the second minus 4ac over 4a to the second. Now, you can practically plug in numbers. You can take numbers from this thing. Let's say your instructor gives you and then tells you to, to complete the square. You could practically just plug that stuff in there now, and it's pretty much done. And that was not too bad. Now, let me clean that up because it looks like a question mark. We're not questioning if it's equaled or not. So, it's a very rough proof. This is the first time I've ever done this. I know I'm going to need to get a bigger whiteboard. Some of this stuff is going to be really hard to do. And mind you, we just did one portion. And if you go a little further, you can actually solve the quadratic equation, which we'll probably say that in another lesson. So tell me what you think about this tutorial. Did it help out a bit? Did it help explain this? If not, I'll have to see if I can write smaller, or maybe use a pen and paper or something like that, or maybe one day get a smart board and we can fit as much as we want in here. So we start with this here, and we ended up with this. So this turns into this, and well, you get the hint. So, and now if you really want to, you can also go back this way and work your way back. But I'm not going to do that because it's like 3 in the morning and I'm tired. But so that's pretty much about it for this instruction. And if you like these, I'll do more of them. If I'm a lousy person walking through algebra, then I'll just keep this to myself. So hope this tutorial helped anybody out that's stuck with this problem.